In previous slide, the right hand side of the equation was integrated very easily, but the left hand side of the equation is pretty difficult. As in left hand side of the equation, that is actually dx over a minus x into b minus x, it has two different values as denominator, like a minus x and b minus x, and which are being multiplied with each other, and these are the variables. For them we don't have such a formula to integrate them, so we have to partition them as proceed the partial fraction of left hand side. As you know, this one is the equation, and we have to split this the left hand side of this equation like that of 1 over a minus x into b minus x is equal to a over a minus x plus b over b minus x. This is our equation 2. Here a and b are these are the constants, and we have the propose these values, and we have to determine their values by using the basics of mathematics. Like 1 over a minus x into b minus x will be equal to a into b minus x plus b into a minus x over a minus x into b minus x. As these denominators are different, and we have used the LCM concept for this right hand side of equation a, that's why we are putting this one like that. Above equation have same denominator as in above equation. Both the denominators from left hand side and right hand side, these are equal and can be cancelled. Then we will have another form of this equation that will be equal to 1 is equal to a into b minus x plus b into a minus x. How we get this value? Because the red portion of this equation, these are cancelled with each other because these are equivalent and these are opposite to the is equal sign from left hand side and right hand side. So we have equation f. In order to find the value of a here, which is unknown for us, and we have proposed these abbreviations, and we have to determine their values. So we have to consider the values of a minus x and b minus x as 0 alternatively. So put the value of a minus x is equal to 0. First we have to consider that a minus x is equal to 0. Then we know well by rearranging this equation we will have a is equal to x or x is equal to a. Now putting the value of x in equation f, here we go, we are putting the value of x as a, and then we will have 1 is equal to a into b minus a plus b into a minus a. A minus a will be cancelled out, and finally by multiplying b with 0 we have nothing to write, but here a into b minus a will be like this one. 1 is equal to a into b minus a, or 1 is equal to minus a into a minus b, and by rearranging we can write this one a is equal to minus 1 over a minus b. This is the value of a which was proposed in partial. Again we are using equation f in order to find out the value of b. Again we have to consider that b minus x is equal to 0. Before that we have mentioned that a minus x was equal to 0. Now we have the value b minus x is equal to 0 on its turn, then definitely we will have x is equal to b, which is the final of rearrangement of this portion. Now putting the value of x in equation f, again we will have 1 is equal to a into b minus b plus b into a minus b. Now in this part this factor will be 0 due to the b minus b which will be cancelled out, and a multiplied by 0 will be equal to a 0 quantity. Now we have the value of b is equal to 1 over a minus b. Well students, now we have both the values a and b. Now substitute these values of a and b in equation e. Finally we will have 1 over a minus x into b minus x, that is equal to a over a minus x plus b over b minus x. These are the this one is the equation e, and we are putting the value of capital A and capital B in this equation. Now finally we will have 1 over a minus x into b minus x is equal to minus 1 over a minus b. This is the value of a divided by a minus x, this portion, plus 1 over a minus b. This is a calculated or derived value of b, capital B, divided by b minus x. This one is the equation G. Another equation, this equation is the partial form of left hand side of dx over a minus x into b minus x, that was equal to k dt. And now we have the potential to integrate this value with very ease. So integration sign for integration constant for dx over a minus b into a minus x plus dx over a minus b into b minus x. A minus b, this one is constant quantity, and we will take an out of this from integration sign, as we are not integrating the constants. So minus 1 over a minus b integration sign dx over a minus x plus 1 over a minus b integration sign dx over b minus x. Now we can integrate these notations which are coming after the integration sign. Finally we will have minus 1 over a minus b into minus log natural a minus x. It is the result of integration of dx over a minus x. We have studied about this one, how it will be integrated. We can review the slide number 22. Okay, plus 1 over a minus b into minus log natural b minus x. By rearranging or solving this part, we will have 1 over a minus b log natural a minus x minus 1 over a minus b log natural b minus x. By multiplying these negative positive and negative negative signs, we have this notation. I hope you can understand the whole conversions